Mr. Probst, as I said before, he's senior advisor for the main SME Recyclers Association in Germany, and also, let's see if I can pronounce it correctly, lecturer for anthropogenic material cycles at the renowned RWTH Aachen. Mr. Probst, what is the status quo of mechanical recycling for complex plastic waste streams, and what are the potentials that can be reached?
Okay, to be honestly, most recycling is recycling of standard plastics, which are PE, PP, PS, PVC, and PET. And technical plastics like polycarbonate or PMMA, ABS is a very special task. So if you have complex mixtures are in most cases used for waste derived fuels, for substitute fuels. It's very hard to get into mechanical recycling with complex mixtures. One choice is, for instance, if you go to WEEE plastics, you can separate them by sorting, by deep sorting, by new sorting technologies, but more or less half of the plastics of WEEE are lost for mechanical recycling.
This vein, where would you see the necessity for alternative processes to complement mechanical recycling?
Yes, of course. I think thermal use is just one leg of the three legs. And the second one should be, of course, chemical recycling. And our first choice is, as long as it fits, is it working, of course, mechanical recycling. But I'm a chemist, and for instance, I'm a favorite of techniques and technologies like solvolysis. So solvolysis gives or results in very special oligomers or monomers, which can be rebuilt to plastics or other substances. And so solvolysis was one of my favorites. Or the next one is the so-called physical recycling. You have a solvent and after that precipitation, and that's also a fine idea. The solvent precipitation technique is used for polystyrene, for instance. And these are my favorites in chemical recycling.
Thank you very much. So the understanding would be that, first of all, there are potentials also for elevating mechanical recycling, and only after that we could look for those waste streams that are really not possible to be recycled in a different way. Also, additionally, maybe artificial intelligence can elevate the potentials, of course, for both approaches to recycling, mechanical and chemical. Johannes Leyer and his brother described WeSort AA on their website with a goal to live in a world in which 100% of recycling is possible, meaning that all waste can be repurposed for new products. So improving the sorting of plastic waste will be one of the main factors here, of course. How can artificial intelligence support this mission?
Okay, then we just switch to the microphone, sorry. That's a very good question. AI can help for several tasks within the recycling industry. At WeSort, we try to address mainly two of them. One is to have more intelligence in the waste stream itself in order to identify impurities, harmful objects, and have a better sorting quality in general, because we really believe in increasing sorting quality is the main factor for having better sorting, especially for the recycling processes of mechanical recycling and for the chemical recycling processes as well, in order to have more homogeneous material streams, in order to post-process them better. And another one where recycling or AI can help in recycling is to do plant control and find great hyperparameters for operating or recycling plants, for mechanical recycling and for chemical recycling as well. So that's the main two things where we can help. And what we basically do is we place sensor systems on top of waste streams, and we use object detection algorithms in order to identify what is going on the waste streams. And then we get a very, very granular analytics of the waste stream itself, what kind of material is in the waste stream. And this information gives us the ability to really fine granularly control sort plants and have a better sorting purity.
Maybe if you know one more question related to the production of plastics in the end. Unfortunately, due to the volatility, sometimes the oil prices are higher than the case for recycling. The markets is a better one. A bit after, it's lower again, and the challenges start to increase again. Would you say that with your technology and the impact it has, it can also reduce, at the end of the day, lower the costs of recycled plastics?
Yes, I'm pretty sure we can. I mean, what AI can do is AI can compensate a lot of machinery, which is at the moment necessary in order to have high purities. So I guess in the end, our sorting plants will be more intelligent in the next 5 or 10 years, and we will get rid of some steps in the recycling process, and this makes, of course, the process way cheaper. And I guess another thing what we can do is to build completely new streams, because we do have a completely new layer on the recycling industry, on the waste stream, and we can build recycling streams by sorting by product type or by brand, and really close loops there by giving the opportunity to hand over the material to original product producers.
Thank you very much. So we can deduce artificial intelligence can further elevate the current potentials and also play a role in lowering the cost for recycled plastics. But at the same time, for those applications and waste streams which still will not be able to be recycled mechanically, chemical recycling technologies are presented to be the better alternative to incineration, as we already spoke about in the very beginning. Mr. Hawks, can you elaborate which chemical recycling technologies exist and which one Carbolic operates with?
How many hours do we have to elaborate chemical recycling?
We probably need 3 or 4 hours.
First, plastics are a technical product. The most powerful material that we have in this world to secure, to feed the people, to have health, to care for health issues. So plastics, without plastics, it won't work. But plastics are a technical product that have to be managed in a technical way. So the loop, when we want to close the loop, we have to add technologies, as we do in the plastics. We have to get them to put technology to make them reusable again first. There will be a discussion if Solvolusis with water-based solutions, or where the polymer is not modified, will be a mechanical or a chemical. This is all, it is only theoretical discussion. What we need is that for every kind of waste there are suitable recycling options, and we have to develop appropriate technologies to work with these kinds of waste streams. And some waste streams can be handled in a mechanical way, and it is a resource recovery where the resource can be used immediately in the same kind of proportion. This is okay, and this is preferable. As soon as we talk about resources that cannot be used in a way, we have to regenerate. And the nice thing about plastics is that we can regenerate. We have to add energy, and we can regenerate. We can recover the basic elements for this. And these are hundreds of technologies. Call it pyrolysis, call it solvolysis, call it gasification, and there are the boundaries are not always clear. This is why, but it's always an energy intensive method, because it is always a regeneration trip for the molecule. And if we talk about plastic recycling, I would prefer to talk about carbon recycling or hydrocarbon recycling, because this is the resource that we're talking about. And the plastic is a hydrocarbon that is modified normally by additives and other compounds that give them a certain quality or for a certain use. It's designed for a use, and if we want to use it for another way, in another way, we have to take out the specifics and give it the natural or the neutral form again. And this is all about chemical recycling.
As a follow-up, just a very concrete question. Which kind of plastic waste streams end up in your production plant?
We started from the RDF, from municipal solid waste, which means the product that was never intended to go to a physical or to a material recycling plant. So mixed and contaminated plastics is what we are aiming for. And mixed plastics also means multi-layer film, multi-layer plastics, or plastics that have additives that are used, that do not serve the need anymore. So plastics out of use, where mechanical recycling is not suitable.
Is the quality of your recyclates comparable to virgin plastics?
We do not generate recyclates. We generate basic material for new polymer production. It can be even better if you generate monomers that can be used in a very easy step to form new plastics again. But sometimes it's like pyrolysis oils that can go to a cracker or have to be split to go to a cracker, and can need all the steps that fossil resources need also to form plastics again.
Right. So we talk now a lot about chemical recycling for mechanical recycling, and of course, I think we can all agree that this is a very important building block for the transformation. At the same time, the question might be, will it be enough? Will it be enough for the transition towards a sustainable and also to climate neutral future? So we're very happy to have this vision here to just address the question that so far the discussion has mainly taken place in very, let's say, developed economies with infrastructures that also allow these approaches to work. And even here we see that we have lots of potential to reach. But what would you say? What is needed beyond that?
Yeah, thank you very much. First, apologies for being too late. Yeah, we all love the German train system, I think. Yeah, thanks a lot for the question. I'm speaking today on behalf of an environmental and development organization, and we try to focus the bigger picture, so the overall scope. And I personally studied environmental engineering, and I was very concerned that we always seek and offer end-of-pipe solutions to the really global problems we face today. Yeah, and I think we have to step back and zoom out for a moment to see really the magnitude of the problem, because when we face plastic waste, it's first, it's too much. Secondly, it's too polluting. So most of the waste we find on beaches worldwide is of plastic. I think 85%. It's too harmful. We have very toxic substances in plastic waste that ends up in the environment. And we need to find ways how to reduce those waste streams. And here I think comes the very charming circular economy with all its hierarchies into play. And that's not, I mean, we are not starting with recycling. We are starting with reducing and reusing our products. And I think it's here where we have to start, and where we really have to transform our chemicals industry, because it's not about developing further one-way disposables, but rather finding reusable alternatives. We have to push remanufacturing and refurbishment to an industrial level, and we have to reduce the material we are consuming. I think that's what we should never forget. But of course, recycling is also one part of this whole system, and then we have to find out how we get more accountability to the prior stages of our circular economy hierarchy, which are reduce and reuse, and how we get the companies to address those stages before we go into recycling. And I think that's a really big question in the whole transformation of our industries. That's a huge task, I know, but I think we all together have to find also the prosperous and competitive answers here, because we all want the industrial hub Germany. We want to remain it here, but we have to find answers to the circular questions. Yeah.
So you would say you would widen the scope of circularity, like both in terms of its nature, to see it more holistically, but also in terms of geographical scope, if I must say. And I think this is exactly what also Nicola Lelli is doing with the Alliance to end plastic waste. Of course, ending plastic waste starts with avoiding littering and landfill, an issue that's already challenging and important enough for many regions, globally speaking. But in how far does the Alliance to end plastic waste still, speaking about also complex waste streams and recycling in general, to cover this whole topic, also develop solution models for these streams? Can you introduce some of the main models to us?
Yeah, so thank you for the introduction. I was thinking while we were speaking, and you can see in this fair, I mean, we are facing the challenge of three industries or three ways of thinking that are coming together. One is waste, which has its history, its strength and weakness. One is chemistry, which again doesn't use the same language of waste. And then, by the way, there is digital coming up, right? And there's another planet, another world, another way of looking at things. And the Alliance basically is a do tank. We don't just provide papers and opinions and discussions. We do projects. So we have currently running in the world about 50 projects. They range from projects in super developing countries, what we call country level 1 waste management, to just collect the material, until project for reuse in Japan, which is a country level 6 at the other end of the spectrum, where of course you have a certain consumer behavior which probably you don't find in many other countries. So the challenge of finding solution models, which is what we aim at, is that you need to consider, first of all, the context in which the solution model has to be deployed, the technology availability, and the economic viability of certain solutions. So it's not the same thing to do a project in Ghana or to do a project in Germany.
Quite challenging, yeah.
So, but within that space and within certain ranges of waste management maturity levels, what we look for is the solution models means each of the topics we talk about. Recycling complex waste streams could be flexible, could be WEEE, could be automotive, could be some consumer good like mattresses or whatever else. Typically, you need different solution building blocks that come together and get aligned. And they need to be aligned in terms of objective, but they need to be aligned also in terms of value chain. So if the beginning of the value chain does one thing that is not conducive to what the other people do, you start to get losses and losses and losses, and you end up with very little results. So when we do projects, first of all, we try to understand the context. Then we try to understand where is the weakest link in terms of solution. What is the link that if you could upgrade with technology or not necessarily with technology, could be just consumer behavior, it could be education, it could be in other ways. How can you develop that solution building block to come to a level that really creates an impact? And then once we have that, how do we align with the value chain to make the maximum out of it? And what we do, because we are a non-profit, whenever we do these projects, and more we are doing that, we want to, and we do, blueprint the solutions. So we tell the world, if you have this problem for this specific waste stream in this specific kind of context, this is one way how you can optimize your resources, your financial support, your capabilities, and your technologies. And then we blueprint the solutions, supporting potentially also replication, as we call it, because for us, a solution model is not a solution model if it is not replicable. So if it cannot be replicated by other people who are not necessarily involved in the project, it doesn't help to create impact. So we publish this, what we call playbooks. We published 2 this year. We will publish 5 next year, trying to take our experience from the project we do and make it available for anybody who wants to replicate it.
You mentioned technologies. Now we can assume that maybe in some countries in which we don't have this infrastructure for collection, sorting, etc., that the system must be built up almost like it's been historically built up. But do you think with technologies like artificial intelligence, we could maybe even start with a second step in some of these countries and regions?
Yeah. So we have a project that we found on advanced sorting, let's call it like that. It's not AI driven, which I think is quite a popular project called Holy Grail, which use an alternative technology to AI optical recognition. But I think we should be agnostic from the technology. Once again, we should use the technology that is best fit for that context and for that application. So we found Holy Grail because we know Holy Grail can sort material at very high resolution. I mean, this has been tested for many different materials. You can sort up to 98% specifically on a target application. But we see the challenge that the technology, once again, Holy Grail is a good example. The technology is almost TRL9, so it's done. But now it's about adoption. And adoption is always a financial challenge, but also requires changes of the way people operate, changes of the way people think about this solution. So we need to support with project this change. So Holy Grail is a great technology example, but without that change of behavior and alignment of the value chain will not have an impact.
Yes, maybe we can hear something about some further projects of the Alliance later in the second part. And so I think we understood very well now that taking the global perspective for all kinds of waste streams does not mean doing the second step before the third one, but not necessarily, but we have the option really depending on the context, on the culture probably too, and what you can find in a specific region. And at the very end of the day, to take the usage of all our options available in the most intelligent, you said agnostic way. We would think that the progress could be understood to just be able to move forward in certain areas and then in others, just because it mirrors the history of waste collection, but it seemingly goes a bit in a different direction, and of course also gives hope for a bit faster progress than we have seen so far. I hope that we have received at least a brief overview from mechanical and chemical recycling, sorting and collection technology to a more holistic view of sustainability. And of course, always having the implementation in mind. In our second round, we would intend to focus particularly on the next steps, and how to move forward. But before that, I'd really like to give some space for a few questions, 2-3 questions from the audience, and your impression of this overview, with your questions concerning the input that you just received. So if you have any questions, then please just go for it.
For each question, you can get a beer.
We'll see.
Hello, Mariano. Is there any examples of optical sorting or advanced sorting that can help in the open air dumpage in places like Mexico that we don't have sanitary places? I don't know if you could tell me so.
To be honest.
Well, can you repeat the question?
Is there any way to integrate the optical sorting or advanced sorting into the open air problems of the dumping sites, not well-developed countries?
I see. Yeah, I guess that's. AI can help in two different kind of manners in order to address our plastic recycling program. In more developed economic worlds, it's really important to work together among the whole stream and propagate information back from the process steps to the forward process steps in order to enable them to separate waste as early as possible in order to help the later stages of the process to have the best material as possible for their streams. So that's what we can do in order to close the loop in well-developed countries. In more emerging countries, I guess, where AI can help as well is what we can see at the moment is we have sorting is getting more software driven, and a lot of the intelligence which is in the sorting systems right now, which is really a lot, is moving from the hardware and sensor part more into the software part. And software is really easy and cheap to replicate. And this gives us the ability to reproduce very cheap sensor sorting technology, which we still have hardware, of course, but having cheaper software enables us as a society, especially in emerging countries, to build cheap sorting solutions, which are pretty good at sorting compared to more developed countries. And help them to build sorting plants with very less capex.
Yes.
Also, if I can help, we do have projects for landfill remediation and the use of landfill material in some developing countries. I think AI optical sorting at this stage is too sophisticated a technology. But I have to say, we see that with education and potentially even combination with simple technology, you can help the informal sector in some countries to improve the quality and the amount of the material they extract, for example, from a landfill. Because there are these days simple hand machine that you can point to a plastic part and it will tell you which material that is. And there are some technologies coming up to do simple separation, even just on a belt. You will still need a minimum, material recovery facility, like a dirty MRF. But some of this technology can help at least to start picking from the waste, not just the PET bottle, which is typically what the informal sector picks, but perhaps high density rigids. perhaps even some flexibles, which is the project we do in Ghana, for example. So there is room to improve how you can extract more value from that material, which typically drives the economy, the circular economy, to start. And then once you start with some material, you can always expand and have more financial viability to go to more sophisticated technologies. But there is something for the basic as well.
Yeah, thank you very much for the interesting discussion. I have a question because you talked a lot about the need to connect the designers with the recyclers as well, so that you can already in the design phase consider to make products recyclable or separable or even reduce the amount of plastic. How do you connect with those designers? Are there platforms on Plastics Europe, or do you have other industry platforms? Where does the connection happen?
Would you like to start?
Okay, the design for recycling is a legal issue given in the German PPWR, and it's a main issue, design for recycling or eco-design. What happens is we have got a system of licensing packaging. So you have to pay a certain amount of money for glass packagings, for plastics packagings, for paper packagings, and you can reduce costs by better recycling products. So I think that is the best driver, the most important driver to connect design for recycling with recyclability and licensing. That's my way to do it. So there are a lot of questioning which is arising at the ZSVR, that is the Central Authority for Packaging Managing, for better design, and there's a lot of questioning in all these associations dealing with plastics, plastic waste and plastic packaging. And I'm looking very positively in the future, and a lot of packaging are turning now, and they're turning for about 2 or 3 years. But, sorry to say that, but I see a lot of packaging going also not the best way. It is fiber composites, because fiber composites cannot be recycled very well. More or less all fiber composites go to the thermal use. Then we have got a lot of composites for paper and cardboard. And what happens is we have paper and cardboard with a very thin layer on plastics on it, which can be recycled in the cardboard area or the cardboard recycling, but gives additional costs to get the plastics off. And even within the plastics flow, we see a shift. We see a shift going away from the polyolefin packagings to the PET packagings. Of course, PET bottling is a very fine idea. Sorry, you should assume that it's a PET bottle. PET bottling is a very fine idea, but if a PET trace or PET fibers, anything like that, normally they can not be used for circular economy or for circularity.
Yeah, thank you very much for the question. And of course, it's also a topic that we at Plastics Europe are dealing with. At the end of the day, Mr. Probst already spoke about some solutions, particularly thinking about modern materials, but of course not solely. And there are a lot of incentives from society and also from politics that can stimulate this. By the way, if you would like, later we'll be back at our booth at Plastics Europe here in A6121. We could also have a quick talk to go a bit further on this. By the way, our panelists are already looking at the time, ticking down. I just wanted to say that before the discussion, I went to our colleagues from the fair. So we have time until 12:30. That still means that we want to keep going on, but we don't need to be as afraid as we would think.
And please, I want to add some questions, some answer to this question. It's not only about design for the recycling when we talk about the product. It's also designed for recycling when we talk about the business model to put the product in the market. When you put a product in the market and you have an end of life solution with this product, and you have a take back program, and you create your circles, this may be development that gets you from a product from a producer of a product to a provider of a service. Yeah? So there is this design for recycling for me is also a design for circularity, and not only for a technological aspect that comes with the product. I would like to address this, because this is sometimes beyond the expectations or beyond the plans of a product manufacturer. They should not only talk about the product by itself, but also on the way to get it back.
Yeah, thank you very much. And since you already replied to the question, you were also the person to start with in the second round. So my question would follow immediately. What would you say is the next development step? We talked about technology, about some more basic solutions as well in some development countries, and mechanical recycling, design for recycling. What is now the next development step, and what framework conditions do you need for scaling up your business? It can be the recycling.
Oh, it's nice to scale up a business, but does this match the needs for a circular economy? I don't know. For our business, the next step is scaling up and making it available in a wider sense, because we think we can provide value to a process or to materials that are currently being burned. So we talk at our specific base, we talk about 10,000 tons per year modules that we can place at the place of waste origin. So where waste is originated, the waste owner can provide or can make use of it and add value to his waste stream. I think this is easy. On a global basis, adding value to waste is the solution. And if there is a fair price for the resource, and we should leave the waste discussion and start a new resource discussion on that. So if we accept that waste as we know it is a resource, and the ones who make this resource available for a circular market again should be rewarded a fair price, I think this is the discussion we have to start. And this means in our countries here is that we have to start about thinking, generating secondary resource segments rather than a waste sector and a chemical or a packaging sector that are separate, because most of our problems, and this is the answer of what we need for developing our business, is that we have to be compliant with the waste sector. We have to be compliant with the chemical sector, and there is no natural trace between these. So there is a lot of regulatory changes to be made or adaptations to be made to get this secondary resource sector in place.
Thank you very much. Now it's a bit of a radical jump again back to artificial intelligence, but still to address just a bit of a practicality question. You have your artificial intelligence technologies in usage already. What are your experiences so far? If you wanted to summarize it in a nutshell, and also maybe on the horizon mark, like maybe 1 or 2 areas where you see potential to still be developed.
Well, that's a great question as well. What we see is when we bring AI into production, people, especially sorting plant operators, are very, they really like that technology, and that they really see the impact right now. That's something we didn't have 2 years ago. So there is a huge change in the moment going on. So everybody is interested in such a new technology, and everybody is willing to try new technology, which is a pretty good thing, I guess. So the recycling industry is really open-minded, I guess, in this specific case. That's great. And what we can see as well is we are able to address completely new use cases which aren't addressable before, like sorting electronic devices, WEE, or other kind of material which wasn't sortable in the past, or PCBs, or plastic in food and non-food fractions. I guess that's a great playground where there's a lot of opportunity. And I guess we are really at the beginning, and there is a lot of, like already mentioned, a lot of things which need to be done when it comes to regulations, especially to have good regulations, because it's a very, very, very complex problem we are facing. Unfortunately, there is nobody from the packaging industry itself, which would be also beneficial for this discussion, to enable the packaging people to build great products which can be sorted out in the next step. And what really would help and which holds us back at the moment is to work together in the industry, together with all participants along the value stream. I guess that's necessary beside regulation, of course.
You're talking about working together, cooperating with the industry. So that means I would like to directly hand the next question to Mr. Probst. How do you assess the timely potential and implementality of artificial intelligence for improved recycling from a very practical perspective from your member companies?
Okay, the question is application of artificial intelligence beyond sorting, more or less. I think there are a lot of possibilities to do that, but to give you a concrete point is perhaps in collection. So if you go to the recycle chain, all and everything starts with collections. The better the collection, the better are the recyclates built from that. So first of all, you have collections and sortings and pre-processing, processing, and recycling. So the main issue is collection. And if you are here at the IFAT, you can see collection bins which are underfloor. And they have a huge tube on top in which you put your waste. So for instance, packaging waste or e-scrap or whatever it is. And at that top tube, you can have a control system. To control whether in a packaging collection tube, only people should give these packagings. And so the weight has to be screened, and of course, perhaps also an X-ray could be made, and this is helped by an artificial system to get that information. And if anybody gets into these systems, waste which is not according to the collection system should be stopped. So I think artificial intelligence can help very much to improve collection.
So we're not just talking about sorting, but also about collection here, which of course even enhances the field of progress that we can make in the next years. And of course, nevertheless, still, Ms. Wichen, you already pointed out how like a holistic approach to a circular economy for plastics could look like. I would also go a bit in this direction for the second question. How would you recommend, we talked a bit about regulations, how would you recommend to set the political framework in order to incentivize circular economy? Maybe, of course, we can talk a very long time about that, but maybe you could give like one or two concrete examples.
Yeah, thank you a lot. I think before I would like to put the question back and ask again, I don't know if I missed that in the beginning, but what is it if we are talking about complex waste streams, and is it always as unavoidable as we assume right now? So, I mean, surely we will talk about very complex such as rotor blades for wind turbines in the future. I mean, we will need the very complex chemical recycling to treat those wastes. There will also be product streams such as mattresses we really don't want to reuse. So for that, of course, as well, we need it. But I mean, I also see a very rapidly evolving market of ever new technological devices with very short lifespans. And I think we have to ask the question here, do we need all these products in our society? Do we want them? Also, if we talk about packaging waste, polluted packaging waste, which we want to go to chemical recycling, do we need that much packaging? I don't know. I think that those are discussions we have to discuss in our societies. Yeah, and I think, unfortunately, we spoke already about the PPVR, which will bring along a lot of substitution effects. You pointed it out, and I think that won't help us here, unfortunately. Yeah. So the focus must be on minimizing the complex waste streams somehow, and we need to take the hierarchies of our circular economy more seriously and translate it into a regulation framework. So I think it requires binding regulations for eco-design. I think the colleague left already, but it was a very important question. Here I think we have to look at the EU level right now, where the ESPR, the eco-design for sustainable products regulation, is elaborated, and where for every product stream we want to define an eco-design framework. And that will be very, very interesting in the future. And also a well-functioning system of extended producer responsibility. Mr. Probst already spoke about it. So the ambition level for us has to be very high and very much focused on that. And yeah, well, however, I agree with you that for certain and very specific waste streams, we will need chemical recycling. And here we really have to set a right, sustainable and environmentally friendly framework. And here we have to ask the basic questions. How do we ensure that chemical recycling does not compete with mechanical recycling? Very important. How do we ensure that chemical recycling is not just plastic to fuel? That it doesn't hinder us from recycling-friendly design and avoidance efforts. And also I think always the elephant in the room, but how do we guarantee transparency for the end consumer? So we have to speak about the mass balance approaches. Yeah, and all these questions must be answered before scaling up the chemical recycling, and for the regulation, we have to find intelligent answers to that. Yeah. And if we see now the magnitude of these problems, and we know that reduction has to be one part of the solution approach, I'm also very interested how your alliance is addressing this on a global scale, because you are representing the big producers, I think, from the plastics industry. How you address reduction, or I don't know if that's also part of your scope. Yeah.
Yeah, I mean, it's a complex topic. It's being discussed while we speak at the Plastic Treaty as well, at length, right? And many governments have different opinion on the topic. I mean, again, the Alliance is a do tank, so we do projects. And then when we look pragmatically how you can tackle, reduction, I think the way we help, and we do it in many of our projects, is, first of all, as you said, if you start for design for circularity and design for recycling, you should always consider, for example, down-gauging certain parts. So there is a lot of room in reducing the material used just by optimizing the performance of that part. And then there is a lot about using the right material with the right properties in the right application. So, because if you talk reduction in the big scheme, we need to convince consumers, which is a big task, right? But if you talk in practical industrial terms, there is a lot to do to optimize the way plastic are used today. By the way, there will be certain application for where it doesn't need to be used, but a lot of the application where plastic is used are useful for the climate impact and stuff. So we need to think more, how do we optimize the resources we have? And there is a lot to do. I mean, I think the comment on design for recycling, I fully subscribe to that. I think in packaging, there is quite a good basis by now. There are, regulations like Recyclas, like CFlex for flexible. But for example, in other waste stream, design for recycling is still at the very beginning. I believe we need collectively to do a much better job for electronics, for automotive and stuff, because it's not just the fact that if you design better the material, you can separate better the different, the part, you can separate the materials and recycle them better. It's also, if you have to dismantle an instrument panel of a car, today takes perhaps a couple of hours of labor, manually. That makes the process economically unviable as it is today. So we need technology to do that better, but we need also probably to redesign those parts in a smarter way. So there is a lot of room. And when we do that, we can reduce the use. So this is what we look at as the lines. But if I can add just one more topic, we need to look at systemic solution at scale. We need to get to scale. I mean, if I take the example of mechanical recycling, for example, there are a few thousand plants of mechanical recycling in Europe. I don't think they all use state-of-the-art technology. They don't all use best practices. They don't all focus on specific specs for specific end markets, because historically this was not how they were designed and built. So we have a lot of experience now how we do that. I make an example. With the Alliance, we have a project for flexible recycling. CFlex, which is an association of flexible producers, developed a new process, but this new process is not implemented for mechanical recycling because it's an investment and nobody wants to take the risk to invest that amount. So we are trying to de-risk that investment to show that if you do a plant with state-of-the-art technology, you can increase the percentage of flexible recycled material that you can extract. Now, will it be adopted in every recycler? No. But is there room to do more? Yes. Even in Europe, of course, there is much more room in Africa, in Middle East, and in Asia. So, more, again, using knowledge and best practices and try to get them as broad as possible will help us to solve the problem.
Thank you very much. Just one thing before jumping to the concluding of the panel, maybe to give the chance one more time to Mr. Probst, just for a quick reply, because I saw the need for that.
So I'm sorry to say that, but I object at the idea of burdening, because plastic industry is an industry of more or less medium, or plastic processing industry is an industry of medium-sized companies. And the products are produced as a wide variety. You have a variety of plastics, we have a variety of products, and this is the interesting point. So if you try to get that together, you would instabilize, first of all the industry built up for 30 or 40 years. Why to do that? Secondly, that industry, the plastic recycling industry, is adding to virgin materials in a certain point, recyclates and products generated. So if you have scaling up would mean to add more, but the conjunctural aspects would crash into it. So we have got a lot of periods of short plastics, and then plastic recycling helps to overcome this crisis. So, but if you have larger sizes, all these plastics will also be a part of these conjunctural systems. Then I would like to add one point is chemical recycling and mechanical recycling. There's always a question, is there enough waste for them? They compete, it's a hard competition, but of course, there are a lot of possibilities to use plastics which are going now to thermal use for plastic recycling. So for instance, plastics of the industrial and manufacturer waste collection system could be shifted to mechanical recycling or chemical recycling. Nowadays, we are using more or less most of these mixed polyolefins of packaging, but there's a huge storage, a huge potential of bringing plastics forward from other kinds of collections. Okay. So,
Thank you very much.
Just for clarification, I didn't advocate for consolidation of the industry. I advocated for using the best practices everywhere, which is something different. It's not about having bigger companies. It's about taking the lessons of the things that work and try to use it in more places.
But we still see there is still the need for a bit of discussion afterwards.
Yes, of course. That's
In any case, I hope that we managed to give a bit of an overview of the different innovative recycling processes that exist and that also can be developed in a very timely manner, from design for recycling, mechanical recycling and chemical recycling, to brand new digital artificial intelligence technologies that will push sorting and also collection forward significantly. And of course, we are also really well advised to consider that recycling is a core, but not the only building block, not the only building block for a sustainable future. So we need to use products longer, if possible, also for some applications in cases, think about refusing the usage in some areas, and also must make applications much better repairable than it is for the moment. I know there's a lot happening in the European level, and that's also good that it's the case, but there's still a lot to do. And moreover, for having success in all regions of the world, we must understand that really different local contexts and scenarios are very different. We must understand them better. I mean, we use whatever is proven to be applicable from our toolbox in the specific scenario. So from the regulatory conditions and framework that we discussed regarding Germany and Europe, of course, only, or at least mainly, we understand that a level playing field for recycling is crucial. It asks for quotas for recycled content, and we talked about PWR. This could also be like 2 more panel discussions just about that, or even more, for recycling. And the PWR sets important progress here. There are aspects that are very critical. However, the quotas could provide more certainty for investments into both mechanical and chemical recycling. Yeah, for the end of the day, we talked again about mechanical and chemical recycling. So we must really try to be very concrete about which streams will be covered by mechanical recycling and which really can only be covered with chemical processes. And for this, I would, at the end of the panel discussion, just allow myself to ask one last question, or to rather make a suggestion to Mr. Probst, to just sit together in the next weeks up to come, and if you can, maybe to think about a list regarding these just mentioned waste streams for mechanical, chemical recycling. I'm confident we can reach much more clarity and agreement here to strengthen the collaboration of the whole plastics value chain much more. Would this be an idea?
Yeah, of course. Okay. What we need is to work together against plastic bashing. So I'm always very much surprised of all this plastic bashing I'm observing in legislation, in societies, and why is this bashing? The bashing is because there's a lot of pollution with plastics. Yes, why? But why is this pollution here? Because there's a lot of countries which have not any working waste management system. If there are no collection sites, if there are no processing sites, of course, what should people do? They will throw it away in anywhere. For upcoming countries, it is very important for me to have this waste management. And the first waste flow to see is, unfortunately, it's plastics. So plastics shows you where is the lack of management, where is the lack of society, where's the lack of government, where's the lack of politics. And these people around are organized in the circular alliance. They do not want to recognize their lacks. That's it. Sorry.
So that means in order to really progress here for the sake of the end of the day of the environment, of ecology, I would be really looking forward to doing so together. And yeah, the same applies, of course, to all panelists today and the approach that you represent. Let's really stay in touch. Let's organize meetings like bilaterally, but also up to public discussions like today, and come together because, you know, in the mission that really unites all of us, right? To create a more sustainable world for us today, but also for all who want to enjoy life here in many long years up to come. So, yeah, thank you very much.